All right. Well, good afternoon, everybody out here on the East Coast. Good morning to everybody out west. Thank y'all for joining today. This is the latest in InCab America's webinar learning series. My name is Tim Buffkin. I'm the National Sales Manager for Broadband at InCab. And today we're going to be going over what we're calling Fiber to the Home 102. So thanks for joining, and we'll go ahead and get started. So just as a heads up, this is RCEP compliant. So that does mean we meet the standards and the requirements of RCEP, and you can learn or you can earn continuing education credits. After this, we will send out a link to everybody that's attended after this, so you'll be able to get on, take a quiz that's related to this, and earn your continuing education credits. But just so that it does not mean that RCEP approves or endorses anything. Just means that the general presentation itself does meet RCEP standards for continuing education credits. So what we're going to talk about today is it's going to be a little bit of things. If you were able to see the Fiber to the Home 101 presentation I did, we're going to kind of refresh on some of those concepts. So it's just talking about the building cable or building fiber to the home and ADSS in the power zone versus going strand and lash in the comm space. We're also going to talk about some costs and install and maintenance implications in regard to the underground portion of your build. And then we're going to go back and revisit a couple of the fiber to the home or the outside plant architectures, but we're going to look at a couple new ones and go a bit deeper into what makes some of these different from a design standpoint, a light loss, light budget standpoint. And then we're going to go a little bit deeper into looking at some service drop options, how it affects install, cost, things of that nature. So again, just a brief overview, look at ADSS in the power zone versus strand and lash, conduit versus direct bury, what's the cost difference there? And then again, lastly, we're going to look at a few different ways to deploy fiber to the home, whether it's going an active Ethernet approach or going with the GPON approach. And then we'll look at some of the pros and cons of each one of these and how it relates to your specific build. So we've done the intro. The presentation itself is going to go about 45 minutes. During the presentation, feel free to use the chat if you have any questions or comments. But typically what we'll do is at the end of the 45 minutes, we'll go back through the chat. Any questions there are, we'll answer it. And like I said, give us about 15 minutes at the end. We do ask that the questions remain strictly to this presentation, no business questions. If you have a question or anything related specifically to business between maybe your company and InCab, we can take that offline afterward. Feel free to email or call me when this is done. So with that said, let's get started. So first, we're just going to look at really just the fiber cable deployment, right? Where are we going to put the cable? Especially for utilities, this is kind of a big question, I'd say, somewhat of a hot topic, or can be a controversial subject. So you got a few different ways that we can go about this, right? Of course, if you're a utility, the most popular approach is going to be going with ADSS in the supply region, right? We're either going to go in the neutral. Typically, in a lot of cases, you're going to be either in the neutral or below the neutral, just depending on what your current infrastructure looks like. Going above the neutral is an option as well. Again, a lot of these are going to be kind of case by case, but again, traditionally, you're going to be looking at going neutral or below the neutral for your cable placement, your fiber to the home build. The other thing that's going to be very common as well, and kind of comes from more of the traditional telco background, is going a lashed approach in the comm region, right? So you're going to be 40 inches below the power, below the power region, and then depending on how many providers there are, you could see 2, 3, different cables in that area, but they're all going to be 12 inches apart, right? So you've got to stick with that. So that really kind of cuts down on the amount of space that you've got and kind of what you can do in that area. And then lastly, an area that everybody's going to deploy, and whether or not you're a utility or if you're a traditional telco, is you're going to go underground. Sometimes there's just no way to escape that at all. So that's going to be an area that everybody's going to have to get familiar with. So obviously our main options there are, we can either go with putting conduit in the ground and pulling or blowing cable through the conduit, or we can just take an armored cable and direct bury it. So next, we'll kind of go into a little bit more of the details on these specific areas. So ADSS in the supply region. Yeah, again, this is going to be the most common route for a lot of utilities, and then there's a few reasons why. First off is you're going to greatly reduce the make-ready costs that go into this, because when you look at ADSS cable, we can design cables that will specifically meet, what your current infrastructure already looks like. If you have 400-foot spans or 1,000-foot spans, you can get a cable that's designed specifically for you, and even dependent on, again, what your pole structure looks like or the size of your poles. Again, if you need to go up above the neutral to help avoid some make ready, you've got a bit more flexibility there, and so that's why that's really one of the most popular ways for utility to deploy fiber to the home is by utilizing ADSS. The other good thing is there's no grounding involved, right? ADSS means all dielectric. So it's all dielectric. There's no metal, so no worrying about grounding or anything like that. The other thing is you're the utility, so you're not competing against other companies for space. That is your space. You can operate in that space however you deem fit. Obviously sticking along with guidelines and things of that nature. But you just have a lot more flexibility than going down and regulating yourself into the comm space and being a bit more limited on what you can do. The other plus is it's really low maintenance. If you design the proper cable and you've selected the proper hardware, and everything matches the spec that is needed for your network, you really string it up and you're pretty much done. Again, properly designed, that cable is going to last you 30 plus years, right? Barring, of course, weather events or things of that nature. But under normal circumstances, there's really very little that you're going to have to do with that cable and your hardware in the long run. And the installation itself is very similar to conductors. So if there's not really a steep learning curve for your crews to be able to go out there and run a bunch of ADSS cable, it's going to be a very similar process, and a process that your crews are already going to be familiar with. Now, the downside, though, is because we are operating in that supply region, you do have to have either your power utility crews or crews that are certified to work in that space. So in a way that may limit you in regard to who you can bring on board. And anybody that's been paying attention in the industry, there's billions of dollars that's getting put out there, and these builds are happening all over the place. There doesn't seem to be a huge issue that a lot of companies are having with finding people. I was actually just talking with a contractor. They're an engineering firm contractor, kind of a turnkey solution provider, and they've had some issues finding people, but overall, he said that they've been very fortunate that they've been able to get the right people for their jobs. But it is just something to keep in mind. If you are in that supply region, you've got to make sure you have the right people that are certified to be able to get up in that area. Again, this cable it's all dielectric. That means there's no armoring. So it is a bit more vulnerable to shotgun damage, squirrels, rodents, things of that nature. NCAP does offer a rodent-resistant fiber cable, so that does give you an option there. But generally speaking, that is something that you're likely going to deal with in your network. And then lastly, one thing you got to pay attention to is the sag of the cable due to ice and wind. Another thing to pay attention to as well, and I've recently had a customer that's currently dealing with this. They bought two different types of ADSS cables and they installed them one over the other. Well, the cable that got installed on top had more sag than the cable that was on the bottom. So now they're actually in a situation where they've got the cables are crossing each other, and then wind, things like that, the cables are now going to rub up against each other. So it's, again, if it, as long as the cable is spec'd in correctly, you won't have an issue like that. But it is something to keep in mind, especially if you start going, when working with multiple cable manufacturers, you want to make sure that the sag specs line up across the board. And typically any of your good manufacturers can take a spec that you've got and give you one that's not going to give you these issues. But again, it's just something that you do need to keep in mind and something to be cognizant of as you continue your build down the road. The next more popular is going to be, or I guess the next most popular is going to be the lash approach, right? So you're going to run a messenger cable, and then you're going to lash either an armored cable or a non-armored cable to there. So there are a couple benefits here. One, again, you do have the ability to use an armored cable to help you with shotgun damage, to help with squirrel damage. So you do get some protection there. The other thing is too is the cable actually is going to sit beneath your messenger cable. So that messenger cable, if you think of a squirrel running on top, that also does kind of give your cable some protection as well. From a growth standpoint, you can go and just overlash onto that cable. Whereas with ADSS, you can grow and you can add cables, add ADSS cables to your network. It's just going to take some different hardware to make that happen. But then lastly, again, you can use those telco crews. You don't have to worry about finding guys that can get up into that power space. They can get up, get to the splice enclosures, bring it down. So it gives you a little bit of a larger pool to pick from in regard to who's out there working on your network and what do they need to know. The downside, though, and really was probably the largest downside, is the make ready cost that's necessary usually to make a lash approach work. And that could be anything from, your pole spans are too far apart, or your poles can't support the weight, so you've got to go and replace the poles. Different things like that can affect that, and those costs can add up very quickly. I was talking to a contractor in, I believe it was Ohio, that looked at doing strand lash with utility. And they figured out that they had a rather large portion of their area that the make ready cost was going to be about $50,000 a mile. Now, obviously that's a lot of money. And then when you take into account that if a lot of this federal money that's going out has a timeline, right? You have to be able to have this cable up and be able to provide customers in a certain amount of time. So now you're potentially spending not only the extra money, but also you're taking up time and make ready, when on the ADSS side, you could potentially already be out deploying fiber and getting ready to hook customers up. But then, of course, too, at the end of the day, it's about using the least amount of money possible to build a reliable network. And so again, even if you've only got 100 miles of your area that's going to see this kind of make ready cost, that can chew through a lot of that money very quickly. I was actually talking to a customer about 4 or 5 months ago that they went this route, and they spent about $7 million on make ready before they were even able to string up one piece of fiber. And $7 million is a lot of money. Now, again, not every utility is going to run into these kinds of costs, but if you're getting ready to look at a new build, this is an area that's absolutely imperative to look at, and is going to be probably one of the biggest factors on which route that you go. The other part is you do have more maintenance costs involved in this. You look at the picture on the bottom left, and you've all seen this, right? You're driving down the side of the road. You have the lashing wire is broken, it's loose, and now you've got your messenger cable that's run tight, but now your cable is hanging 5, 6, 7 feet from that, right? And I've even seen in some cases where you can literally walk down the side of the road, jump up, and grab onto the cable. So that, unfortunately, that is just a reality of going this route, is you will have higher maintenance costs. You're going to have more truck rolls just to go out and to relash and to tighten up that cable onto the messenger cable. So again, and I don't say all this just to bash strand lash as not a good approach and not a good place to put cable. There are certainly areas where it is a beneficial place to have your cable located in regard to a fiber to the home build. But again, it's all very dependent on your particular situation, what your pole structure looks like, what your infrastructure looks like right now, and then population density as well. Or are we in an area where we've only got a couple houses per mile? Or are you in a downtown area where maybe you've got condos and duplexes, and you've got maybe 70, 80, 90 customers, potentially in a 1 or 2 mile span. So again, just another piece of the puzzle to keep in mind when you're trying to figure out what works best for you. Now, one thing to touch on, and yeah, I mentioned with ADSS, right, going above or below the neutral. If you do go too high on the poles, you will want to look at a track resistant ADSS jacket. And not to dive too much into detail here, we've got some other webinars that Mike Riddle, our president general manager, have done that touched on ADSS design. So feel free to check those out. And he goes a little bit more into what it means to have a track resistant jacket. But do just realize there are some different design types that make up an ADSS cable. But then obviously for a lash approach, and then even as we go below ground, yeah, you've got your standard options of either an armored cable or a non-armored cable. The interesting thing is string and lash in the Southeast, you typically see a lot more armored cable. Historically in the Northeast, what we've seen is a lot of people going more with the non-armored cable approach. But that does seem to be shifting a little bit more towards the armored cable. But again, yeah, you do have some options there as well. And again, yeah, talk about the damage on the aerial cable. Squirrels and shotgun damage are the leading cause of aerial cables. You've also got lightning, fire, things like that. There are some different options out there to help fight against these. The in-cab in-air ADSS FRP Defender is a great rodent solution, or great rodent resistant solution, as we put an additive into the outer jacket, essentially like a call like a hot sauce, right? That's just, it doesn't taste good to the squirrels. However, instead of using aramid yarns as the strength member for the cable, we use FRP rods. So yeah, essentially call that the second line of defense. If the squirrel does happen to get through that jacket with the additive, they're going to hit that FRP rod and then it's going to be over. So the good thing is here is, again, you're preventing the squirrels from actually getting down into the fiber core and potentially getting into the glass itself and causing an outage. If they do chew up enough of those FRP rods, of course, you do lose some potential strength, so you will need to potentially replace that cable down the road. But again, you're preventing an outage here, which is the most important thing. And just some cool pictures of some different tests that we've done in regard to keeping rodents and pests out of the cables. Armoring and FRP is by far the best option to go here. All right, so next we'll look at underground cables, right? Again, kind of one of those things, even if you're a utility, you're going to be operating underground as well. So again, the pros, right? You're protected from harsh weather. Don't have to worry about tornadoes, hurricanes, things of that nature. You can also joint trench. So if you do have let's say a new neighborhood that's going in, you can go at the same time you're putting down your power cables, things like that. You trench, you can go ahead and drop your cable or drop your duct in the same time. So it'll help you save a little bit of money from an initial install standpoint. And then just overall, it's really just gives you a lot cleaner aesthetics. There's even a lot of towns I know of that have basically made policy of nothing can be located above ground. And even to the extent of even a cabinet, like a communication cabinet, or even a transformer, cannot be above ground. Everything has to be below ground. And then lastly, you do have a little bit less of a chance for rodent damage, but as you see here in the vault, they will potentially get their way up in there. And so you still do have to worry about it some, just not near as much as you do with an above ground application. The downside is you are going to have shorter cut lengths. So if shorter cut lengths means more splicing means more money. You do also have to deal with right-of-way easement concerns. Where are you located in the right-of-way? What type of vault? Do you need a tier 22 rated vault, or can you go with something a lot lighter? Do you have to get the DOT involved? Different states all have kind of different policies on how that works. For example, I know in the state of Florida, if you're operating in the right-of-way, you have to be using a DOT approved vault. But in Georgia, I know that that's not necessarily the case. As long as it's not something that's being maintained or paid for by the DOT, then you can use whatever you want. So again, just kind of something to keep an eye on and keep in mind when you do start working with right-of-way easement concerns, making sure you're going through the proper channels and either using approved material, or if there's permits or things like that you've got to get, make sure you go through that route. Damage, you're still going to get it, right? There's I say there's more backhoes than tornadoes. people digging, construction sites, things like that, your cable's going to get, it's inevitable. The cable is going to get ripped up. It's going to get cut. So that damage can take longer to repair than an overhead application. And then lastly, vaults can and probably will fill up with water. So it's vitally important that you're using good crews that are trained on whatever equipment, whatever splice enclosures you're putting underneath the ground, because the vaults will fill up with water. And if that splice enclosure is not completely sealed and it's not prepped the correct way, you will get water in there. And the last thing you want is a splice enclosure that gets filled up with water, and then you hit freezing temperatures, and now you've got basically an ice block sitting underneath the ground. So direct barrier versus conduit. In rural areas, going with a direct barrier, trenching an armored cable is typically going to be the popular solution here. And that's mainly because the cost is much lower than going with conduit. The other thing is the cool thing with armored cables, we talked about rodents. If you are concerned with rodents or you want an armored cable, but let's say you don't want to worry about having to ground a cable like you do with an armored cable, you can actually go with a dielectric armored cable. So the same FRP rods that we use in our in-air ADSS Defender cable, you can do an armored cable that's essentially that exact same cable. So you get the rodent resistance, you do get some solid crush resistance as well, but now you don't have to worry about the potential to carry voltage back to your electronics. You don't have to worry about, is there proper grounding at each one of my touch points. The plus side though to an armored cable is it can be used for locating after install. So again, a lot of that's really just kind of more of a preference thing in terms of what type of cable you want to use. But again, it is the most popular just because of the low cost. Now, on the conduit side, while you do have more costs involved, the conduit itself does give you protection for the cable. There's also no grounding necessary because, again, you're not typically going to pull an armored cable through. Some people do that as well, kind of call it belt and suspenders, right? You got the protection from the conduit and the protection from the armoring. But again, you still do have to worry about the grounding if you're going that route. Now, one thing, if you're a utility that I do like about running conduit is if you do this, now you can take your same ADSS cable that you've got above ground, and you can run that straight down the pole and take that same cable underground. So what this is going to do is it's going to lessen the amount of SKUs that you've got to carry in regard to a cable, right? You don't have to carry your ADSS cable and then carry your armored cable, right? And then got to worry about which crews have what cable. So it's just kind of just simplifies it a little bit more, right? Because again, it's the same cable can be used in the air or underground. The other thing with duct too that is starting to gain a lot more popularity in the US is the use of micro cable. Starting to see a few more utilities go this route, especially in downtown areas where maybe you don't have as much space to work, but it's using micro cable inside of a micro duct. And that really just kind of starts opening up the possibility and the ease of being able to expand your network and grow your network down the road. The good thing with conduit is typically when you put conduit in the ground, you're usually not just going to put one pipe in. You're going to do at least two, if not three pipes. But now what that means is if you want to go back and add a cable, and let's say you run out of fibers and you need to grow, you can just go back through and either blow or pull your cable through the conduit, and you're not spending that install cost of having to do a new trench and rebury a new armored cable. So as we look at kind of the general costs here, and so these numbers I got from the Federal Highway Administration, and these are from some case studies they did about 2 years ago. So do take that into mind with some of these costs. I'm sure with inflation and everything else, these numbers are probably a little bit higher now. But again, all these numbers are from about 2 years ago, except for the conduit on the bottom. But as we look at, again, plowing, you're generally between $1.25, $1.75 a foot. Now take that into consideration when you're looking at the cost of directional boring. Again, $6 to $7 a foot, you're 3 times plus higher on your cost. Yeah, but again, we talk about the cost to be able to put in multiple pieces of conduit at one time. If you do have to come back down the road and do a new plow again, right now, instead of $1.75, and let's say if it's $2 now, 2 years later, right, that $2 is now $4, or it's up to $6, depending on how many times you have to go back. So you do want to keep in mind the potential growth of the area that you're in, but also from an install point, should you have a bad connection, or should you need to maybe replace or reinstall a certain run on a piece of cable, having to replow versus being able to just repair your conduit and pull back through that conduit, again, could be looking at some cost savings there. And then kind of just for the sake of numbers, I thought this was interesting. Looking at actually boring through rock at those numbers, I hope none of you have to deal with a lot of that, because $270 a foot, wow, that's going to add up very quickly. And lastly, just touch on the cost of a conduit. Reached out to a distributor friend of mine this morning that said he was currently quoting about $1.80 a foot on conduit, just a standard 2-inch SDR11. So yeah, again, call it between $1.60 to $2 a foot. But one thing to keep in mind, conduit is 37 weeks out right now, and this is according to him. So as you're planning and you're looking to start, if you have areas that you're going to be putting conduit in the ground, you need to be looking at ordering it as soon as possible. And lastly, I did a webinar on this a couple months ago where we talked about actually your blown in infrastructure, blowing in infrastructure, utilizing micro cable and a jetting technology to be able to deploy it. This allows you to be able to install cable a lot faster than pulling. It also allows you to be able to install much longer runs at one time than standard, pulling cable through conduit. It also just gives you a lot more flexibility in regard to growing your network down the road. Again, either adding cables, or even from a leasing standpoint, being able to lease out duct space. 5G is the big thing right now, and a lot of times what's happening in rural areas is your cell companies are looking to rely on local ISPs, local utilities that have deployed fiber, and utilizing that fiber. So again, kind of one of those things, there is a little bit more upfront cost involved, but again, as you look at a network that you want to have in place for the next 50, 60 years, I do think it is worth looking into going this route. And again, right, it's possible that this can help generate alternate revenue streams as well. And then lastly, just look at either going above or below grade enclosures, right? Going with a pedestal that sticks up out of the ground versus having an enclosure beneath the ground. In rural areas, pedestals are going to be a lot more popular. One, because they're typically on the lower cost side. However, you can beef them up. If you look at what's on the right side of this picture, with a vault pedestal combo, you can get up there in price as well. It just gives you a little bit more flexibility, but it's also easier to see in a rural setting where you're driving down, a rural back road for 10 miles. It's a good visual indicator. Downside is the pedestals are a lot more susceptible to machinery, to bush hogs, things like that get knocked over, or a bored kid with a baseball bat and nothing better to do. So again, right, a lot of different ways to go, and a lot of this is really just going to be a lot more based on preference, what you're comfortable with, and what you want. So next, we're going to move away from the actual material itself and look at ways to deploy fiber to the home in terms of the architecture. You've got a lot of different ways that you can design your outside plant from a design and an architecture standpoint. And all these are going to have various effects on how you maintain it, what the cost of the deployment is, what the speed of the deployment is. The first one, and I would say in a rural setting, and really kind of generally speaking, you don't see it as much anymore, but it's what we call an active, or you'll hear an active E or active Ethernet, or like a home run network. All right, so we'll discuss that, and then we're going to look at 3 different popular ways of deploying a GPON network as well. So your active Ethernet network, essentially what this is we are running a single fiber from our central office or from a node, from there straight to the house, right? No splitters, nothing in between other than splices and connectors. So wherever your central office is, if you are serving, or central office or a communication hut, if you are serving, let's say, 1,000 people out of that hut, you will have 1,000 fibers leaving that hut and all going directly to the end user. this is going to give you the highest amount of bandwidth and flexibility in terms of who you're connecting, what kind of services you can provide. Um, but the downside is you're going to need much higher fiber counts, but you're also going to need equipment that's a lot more expensive as well. So really, when we're talking about rural broadband deployments, this just isn't near as common, right? Because again, it's to be able to spend that much money but have fewer homes out in a rural area. It typically just does not make sense. I will say that I do know of a rural telco that deploys this, and they swear by it. So again, not to say that it can't work and that it won't work. It's just not something that you are going to typically see in a rural broadband deployment. What we will see though is going to be your GPON is going to be your GPON network, right? GPON stands for a gigabit passive optical network. Typically, what you're going to see is you're going to leave the central office and you're going to use some form of a splitter. And in your traditional deployments, you're going to use either like a 1:16 or a 1:32 split ratio to feed the customer. So what that means is I'm going to leave the central office with a single fiber, and I'm going to split that fiber either 16 ways or 32 ways, and I'm going to feed customers off of that splitter. So if a single OLT port might feed only 16 customers if you're a lot farther out away from the head end, or if you're close enough in, it might feed 32. So there's different ways to design this, to get us to that kind of a split ratio and still be able to give customers with good high-speed internet. Our three most common types of GPON architectures that we're going to see is going to be a centralized split, a distributed split, and then what people call either a tap architecture, or a lot of times you'll hear it called a distributed tap architecture. But overall, regardless of which way you go, compared to an active E or active Ethernet setup, you're going to be lowering your cost by a good bit here, right? Up to 50% lower on your CapEx, and then 80% lower on your operating expense. So that's the big reason why this is going to be, GPON is going to be a lot more common, a lot more popular than your active network. All right, so let's look at a centralized split architecture. So your centralized split architecture is going to be essentially what's kind of been the gold standard for GPON, in regard to fiber to the home, and this mirrors kind of the old telco days and your old copper plant where you would go hit a central point, and then from that point you're going to split, or in case of copper, right, you would break out that signal and then you would run to your homes from there. So this basically mirrors that same kind of a design. So what you'll have is an FTTH, or a fiber distribution hub, that's typically going to get fed with a 24 fiber count, or higher, depending on how many spares you want. But then from there, your splitters are going to sit in that hub, and then a single fiber will feed a splitter, right? Again, whether it's a 1:16, 1:32, in which in some cases you can do a 1:64. So that one fiber feeds that one splitter, and then if you're looking at the picture on the bottom left, the yellow tails come out of the splitter, and then you can plug your any one of your 32 tails into any of the 288 houses that this cabinet can feed. So again, this has kind of been the standard way of going for a while, and these cabinets can range anywhere in size from a 96 to a 576. And again, that number, the 96, 144, 576, that all that is doing is that's telling you how many customers you can feed off of splitters out of that single cabinet. The good thing here, one advantage here is you can add your splitters as you go. So when you first install the cabinet, you may only put one or two splitters in, but then as you start to gain customers, you go back and you add splitters as you go. The downside is there is a high cost that's associated with these FTTH cabinets. Typically when we talk about the material, the splitters, the vault that it's going to sit on top of, if it's below, if it's a grade level, splicing everything, you're typically $20,000 or so all in, on that one location. So there is a lot of upfront cost involved with that. So again, if we just look at the design, It's pretty straightforward. You've got your 24 fiber feeder, you hit your FTTH that has 9 1x32 splitters in it, and then you're just running point to point from that cabinet, right? So you're on a standard 288 cabinet, you're going to leave that cabinet with 2 144 fibers. And then from there, you're going to run, you're probably going to taper down from a 144 to a 96, or 144 to a 72. And the further away you go, you're just going to keep dropping off drops and paring down that cable as you go. Typically here, when we're looking at a splices per home, you're looking at about 3 1/4 splices, give or take, right? So when we talk about splicing, average splice cost of, call it, about $25 a splice, you're 75, slightly higher than $75 per homes passed just in splicing. Now, what a lot of people, especially in rural deployments, have been doing is moving away from that centralized split design and going to what we call a distributed split architecture. So what we're doing here, instead of having a central cabinet that's going to house all of our splitters, we're going to move the splitters away from that centralized cabinet and drop them along the path of our fiber to the home network. So now what you can do here is you can still utilize that same 1x32 splitter, or you can actually use different combinations to achieve the same split ratio. So in this case, you could use a 1x4 and a 1x8 splitter and still get your 1x32 split ratio. So there's a lot of different ways that you can deploy this, but again, the main thing is you're getting rid of that centralized FTTH location that has all that cost sunk into just that one spot, and we're spreading it out throughout the network. So the other thing is here is typically your splitters are going to be purchased up front. So as you go and you build this out, you're going to be planning on almost as if you're getting 100% take rate, because you've got to design and set your splitters up in particular areas. Whereas with the FTTH cabinet, I'm going to go back to this picture right quick. All these spaces on the left side of this picture, those are 288 homes. So my 1x32 splitter can either feed home 1 or it can feed home 288. So as we go back to this design, though, you are going to have to design it a bit more with an upfront design of, okay, this has to be able to feed this house should this customer sign up. However, the big benefit here is you're reducing your splicing by as much as 3 splices per homes passed. So again, that $75+ now we're dropping that down to less than a splice per home, and that's instant savings right there. So now when we're going to do this 1x4 to a 1x8 split ratio, and I use this guys, kind of the more common, there's different ways to do it, but what we're going to do is we're going to reuse dead fibers, and this is going to help us shrink the amount of fibers and the size of the cable that we have to use. So if we look at our primary splice enclosure, if we take our blue fiber and we feed a 1x4 splitter, we're going to take the first leg off that 1x4 splitter, and that's going to feed our 1x8 splitter. So 8x4, 32, those 8 fibers now coming off that 1x8 have been split 32 ways, and we can run those drops to the house. Our next 3 fibers on that 1x4 are going to get spliced back in to our cable. So those, now our violet, rose, and aqua fibers are all on a 1x4 split. We hit our secondary splice enclosure, and now we're going to pull our violet fiber out because it's already been split 4 ways, and that will feed just another 1x8 splitter. So again, now we can drop our fiber count down, we can drop our enclosure size down, and again, we're dropping our splicing down, and we're still achieving the same result as we got in a centralized split design. So again, we'll look at the design here. So same 288 customers served. We're using that 1x4 to 1x8 split ratio. So now that 24 fiber that we fed the FTTH cabinet with, we're running that same fiber throughout everything. So it's just that 24. There's no 144 fiber, no 96. It's just that 24 fiber. So again, your primary enclosure will have a 1x4 and a 1x8, and then you'll have 3 secondary enclosures that will follow it. After that, it's wash, rinse, repeat. Primary enclosure, 3 secondaries. primary, 3 secondaries. Now, again, there's multiple ways to deploy this. This is not the only way to do it, but this is generally what you're looking at. Say, wash, rinse, repeat in terms of your design. Lastly, we have what's called the distributed tap architecture. This is becoming a lot more popular in fiber to the home deployments in rural areas, especially among electric cooperatives, because this has the lowest upfront costs when we're talking about material, splicing, things like that. This is one of, if not the lowest cost ways from an initial cost standpoint to deploy fiber to the home. So what we're going to do here, instead of utilizing a symmetrical splitter, a 1x4, a 1x8, a 1x32, we're going to use what's called a tap. So a tap or a splitter tap is going to kind of go off the old copper mindset of deploying internet. So to where we're going to have a fiber, it's going to feed into a tap that maybe we call it it's a 90-10. Right. So what that is going to do is it is going to bleed off 10% of the incoming light off of that splitter. Okay. So take, whatever your light input is into that splitter, and you're going to take 10% of that, and then that's what you're going to branch off and use to connect homes to. Now, within this, you're going to have multiple different variations of this tap. You might have a 90-10, a 95-5, 95-5, an 80-20, an 85-15. You're going to have a lot of different variations of this, because obviously the further down you go, since we're not just working with a set number, we're working on a percentage basis, you're going to use different taps at different points. However, where this helps speed up the deployment is essentially on, let's call it going down a rural road. Every time you hit a house, you're going to be pulling out just that one fiber, right? Just that blue fiber, putting your tap in, splicing back into that blue fiber, and you're going to utilize that one single fiber all the way down. So this, like the distributed split architecture, helps you lower the fiber count, drop down the size of splice enclosure you've got to use. And again, we're also reducing the amount of splicing that is getting done here. So as we look at these three, your centralized split architecture is your highest cost to deploy, with your tap being the lowest. However, as we look at from a troubleshooting standpoint, the centralized split is going to be the easiest system to troubleshoot, because what you can do is if you get a trouble call, your technician can go out to that cabinet that's in the central location, and he can test potentially 288, or depending on the size of the cabinet, 288 or more individual fibers from that central spot. And then between there and the end of the house, again, there should really only be splices and connectors. So being able to locate where the fault is going to be a lot easier. Now, as we go down to the distributed tap architecture, right, because we're working off of multiple different taps that are on a single line, and they're all based off of a percentage of light, troubleshooting that can be a bit more complex, because now we got to know, where are we going from, an OTDR readout standpoint? How are those taps affecting what we're seeing? So again, something to kind of keep in mind there. From a material management standpoint, centralized split is going to be one of the easier ones to keep up with. You're going to have one or two types of cabinets, 1x32 splitters, few different types of cable, and then you're pretty much going to run from there. Distributed split, you're going to have kind of somewhere in the middle in terms of material you're going to keep up with. A couple different types of splitters. You are going to have less cable counts to keep up with. So it might be kind of a wash there. However, the distributed tap, you're going to have a lot more SKUs involved with that, because again, you could be using 13, 14, or 15 different taps all within the same network. So especially as we're mapping and we're working on, let's say, expanding your network down the road, all those different taps and trying to engineer and design that can be a bit more tedious and be a little bit more to keep up with. So again, these all have their pros and cons. A lot of it's really just going to depend on on what you're going to do. One thing I do want to note here is we look at the fiber density and how many fibers we need. Again, the distributed tap can operate with the fewest amount of fibers. However, I would definitely discourage you from going too low on a fiber count. just because you can get away with a 12 count fiber doesn't necessarily mean that you should. Yeah, it might be worth it to go ahead and run a 48 because, again, the last thing you want to do is have to go in down the road and install more cable because you didn't do it up front. And again, the install cost is going to cost a lot more than the cable itself. So just make sure you plan ahead and you don't get too caught up in the fact that you can get away with a very low fiber count. Because just because you can doesn't necessarily mean that you should. So, we talk about troubleshooting and planning and growth. I'm going to talk about power budget and loss budget. So when we talk about power budget, that's going to refer to the amount of fiber cable plant loss that can be tolerated between the transmitter, or our OLT, and the receiver, our ONT. So essentially what we want is when we leave the OLT with X amount of light, we have to lose a certain amount of light before we get to our ONT, or else it can overpower the receiver. But we also can't fall below a certain number, or else we won't have enough light to actually be able to provide proper bandwidth. Our loss budget is going to refer to how much loss that there should be in our given plant based off of the amount of splicing, connectors, splitters, taps, things like that. So when we design our plant, and our loss budget is going to be, okay, when we leave the head end and we get to customer on 123 Main Street, how much light should we have lost? Okay, we should see a 20 dB loss between point A and point B. So that's going to be your loss budget. So what happens is you deploy your network, you get out, and your tech shoots the OTDR, and he sees a light loss of maybe 24 dBs instead of 20. You've got an issue somewhere in between point A and point B. Now you can go out troubleshooting. So both of these are going to work together to make sure you're getting the optimum amount of light to the customers. So again, going back to what makes that tap splitter different is, again, we're operating off of a percentage, right? So every time you hit that next tap, you're dropping off a percentage. It's not just a set number. So as we go and we look at, calculating our loss budget, what you're going to see is typically you're going to lose 1 dB for every kilometer you travel down the fiber. A connector, an SEAPC connector, you're going to lose 0.3 dBs. A splice, with splicing technology the way it is now, you're 0.05 dBs, if not lower. Typically a splice now, a straight fiber to fiber splice, we really shouldn't see much of a loss at all. Now on the taps, as you continue, in the example of continuing down that one single blue fiber to connect all the houses, you do lose 1 dB for every tap that you go through. So once you hit that second tap, you have to calculate, in the case of the example that was displayed earlier, if we're going 90-10, you left that tap with 90% of the light that you went into it, minus 1 dB. So now you hit that second tap. If we do the same thing, again, you're moving on with 90% of the 90% tap. So something to keep in mind there. Our typical splitter ratios, though, these are going to be the same pretty much regardless, right? As if you use a 1x2, 1x32, you can typically count on these splitters having, roughly the same dB losses, as long as you go with a good quality, reputable splitter, manufacturer, right? So a 1x32 splitter is going to have 18 dBs of light loss. So, again, from our distributed split standpoint, we looked at a 1x4 to 1x8. Here we've got 7 dBs of loss for the 1x4, 11 dB light loss for the 1x8. Still puts us at that 18 dB loss. So these are some of the factors that you'll take into account when you're calculating your light budget. And again, something that definitely needs to be taken into account when you're looking at what type of architecture you want to deploy. So I'm not going to overly dive into a lot of info here, but I did just want to kind of display some of the GPON technology and how it's gotten better over the years. So kind of the standard was the NGPON 2, right? After that, we saw an upgrade. We had XGPON. Now we're on XGS-PON. I'm sure there's, the next iteration of GPON is already being worked on. But one thing I did just want to touch on this is when we're looking at, if you hear these terms NGPON, or let's say you have a small NGPON2 network that you're supplying some customers with, but you want to upgrade. The XGPON and the XGS-PON operate on different wavelengths. So if you have an NG-PON2 network that you've already got customers sitting on, you can still upgrade to an XG-PON or an XGS-PON, and you can still keep your NG-PON2 customers on that plant. So your XGS-PON is going to operate on a different wavelength. It's going to allow you to upgrade your bandwidth, still connect new customers, continue to grow your network while still operating your NG-PON2 network. So again, same thing for the XG-PON. And then also, again, yeah, as we continue to grow in technology, obviously, your XGS-PON is going to give you a lot more coverage in terms of how far you can shoot that light down the road. And then two, with more power, that means we can also go more splits. So as this continues to grow, instead of using a 1x32 splitter, now you might be in an area where you can do a 1x64 splitter, and now you're hooking up 60, 64 customers on that single fiber instead of just 32 or 16. And again, this is constantly changing, but this is just kind of something to definitely keep up with. And again, there's going to be a lot of cost involved in going with the newer technology. But as you get into this, you've got to plan on future-proofing your network, plan for 10 years down the road. So lastly, we'll look at some service drop cable options. The most common is going to be your standard flat drop or your butterfly drop cables. You can run these aerial or you can run these underground. They're a pretty robust cable. So they're going to be pretty strong underground, but you'll still inevitably run into somebody that's digging in their front yard, doesn't pay attention, cuts the cable. You can go with a round drop cable and even go with a small armored cable as well. You got some different options there. It's not as popular, and the main reason for your standard flat drop cable being the more popular route is just because of the cost. It's a lot more cost effective. It's a lot lower price. So kind of probably the general consensus is there. Well, you know what? If somebody cuts it, the cable itself costs 10 cents a foot, 15 cents a foot. Go out and have somebody replace it and call it a day. A third option, what I'm starting to see a lot more growth in, are figure-8 cables. These are great because they cover much longer spans than your standard drop cable. Standard drop cable, you're typically anywhere between 90 to maybe 140 feet, depending on loading conditions, things like that. Figure-8 cable, you can go up to 400 foot plus, depending on your load ratings. So now what this does, it just gives you one more option in regard to getting from that last pole and getting to the house. Again, especially in a rural area, when you do see some of those 100-foot spans, 150 or 200-foot spans to the house, this just gives you a lot more of a simpler option without having to go underground or add a pole or things like that. So definitely, it's a very viable way to deploy drops aerially. Then lastly, I'll say somewhat of a touchy subject, or I guess controversial subject. Do we want to splice on our drop cables or use connectorized drops? This one, I will say, from a lot of talking to people, it really boils down to preference. Some people just like going connectorized. Some people like splicing on and just having that secure connection. Obviously, splicing on a drop cable, you're going to have a better connection. You're going to have less light loss, because remember, that connector, you're going to have a 0.3 decibel light loss. So if you've got a couple, call it 3 or 4 connectors in your run to the house, you're potentially talking about 1 or more dBs of light loss. However, if we're splicing that on, we don't have that. Does reduce the risk of a dirty connector. Splicer's out there late, trying to plug everything in, get home at the end of the day, and he doesn't clean off the connector, right? Plugs it in. Now you've got connectivity issues. You're going to have to roll a truck back out there. Again, not saying it happens all the time, but it is definitely a possibility. The downside, though, is it does make the reconfiguration a little bit more difficult, because obviously once you splice in that cable is spliced in, that's the customer you're feeding. If you're in an area where maybe you feel like you may have to go in and disconnect and reconnect drops often, going with the connectorized option may be more suitable. Obviously, connector is going to be a little bit more faster from an install standpoint. You don't need a splicer on install. However, I will say that sometimes that argument can maybe get overused of, oh, you don't need splicers. You go this route, you don't need splicers. You're still going to have splicers in your network. So the argument that you can get rid of splicers is definitely not the case here. And the thing is, too, is splicing technology and splicers have gotten so advanced and so easy to use that going and splicing on a flat drop cable is not as near timely or costly, as it was even call it 10, 15 years ago. So I think that's really kind of the area where there's a lot of debate on which is more cost effective, the amount of time that you save on being able to plug in a connector, or the amount of money you're spending to send somebody out to splice on a drop. So again, I won't elaborate more on that, but that's typically where the discussion of this boils down to. Now, a couple of things though that are a fact is you're going to have a lot more SKUs to deal with when you're looking at a connectorized system, because these are all pre-connectorized. So they're going to come in 25 foot, 50 foot, 100 foot, 200 foot lengths. So you're gonna have to manage all that inventory. You're gonna have to keep all that in. That also comes with added cost. So typically from the numbers I've seen, you're adding about $75 per home passed by going with a hardened pre-connectorized system. So again, is that cost worth it to you? Yeah, that's something that that only you can figure out, right? But that is just the case. Another thing is too, from a cost standpoint, is it never fails. A tech gets a call at 3 o'clock in the afternoon. He needs to go hook up a customer. He gets out there. He needs a 50-foot drop. All he has is a 200-foot drop. I can tell you right now that cable is getting cut, or that cable is just getting hung up, and you're gonna have a 200-foot cable that's spooled up on the pole, and that's what's getting used. So again, just from a material management standpoint, there's a lot more to take into consideration there. Versus that technician just having a bulk reel, a flat drop on his truck, and he can reel out 20 feet or 500 feet, do his splicings on the end, call it a day, and go home. So again, there's not really a right or wrong here. It really just kind of depends on your own preference. So as we wrap this up again, right, and I feel like I've tried to say this throughout the presentation, there is no one size fits all approach to doing fiber to the home. What works for a rural co-op in, call it rural Arkansas or Missouri, may not work for a cooperative that's in a more urban area. For example, one of the larger cooperatives in the country, they're doing a centralized split architecture. And it was probably 4 years ago, 5 years ago, I was having a discussion with them, and we were having the same talk. And he said, look, Tim, I understand that what I'm doing is a lot more expensive. However, it's what we know, it's what we're comfortable with. We can design this on our own without having to bring in somebody else. So, and we've got the money to do it as well. So to me, that's a perfect example of what works for one isn't going to work for someone else. The other thing I try to tell as many people as possible is do everything you can to educate yourself on your network. Make sure if you work with a consultant, they say, hey, here's what we think you should do. Make sure they can explain why. Why are you doing X over Y? Why are we doing connectors over splicing on drops? And again, and this isn't to say that what they're telling you is wrong, but you want to make sure that you don't get pushed into a solution or a design or even a product set that 4 years down the road you might regret having. Because again, once the project's done, it's typically going to be up to you to continue to grow, maintain, and expand that network. So I feel like a lot of the cooperatives I've talked to, utilities I've talked to, the ones who have really kind of taken ownership of learning the ins and outs are the ones who have had a lot more success, and I'd say a lot less headaches as they continue to build out. One thing I'll say is from an outside plant material standpoint, stay away from proprietary material. Whether it's vaults, enclosures, cabinets, anything like that, stay away from proprietary stuff, because the thing is, and we've all seen it, right, in the way the market is right now, lead times are out. Lead times on cable, lead times on enclosures, vaults, conduit, right? Conduit's 35 weeks. The last thing that you want to do is get into a proprietary, connector of some sort. And now all of a sudden lead times bump out to 45 weeks, and now you can't get your hand on it. Now you're stuck. So if you stick with products that are non-proprietary, you can swap in and out. If you get caught in an emergency, you can go find something else that can still work with your network. So again, I can't emphasize that enough. Just stay away from proprietary material, because it can end up hurting you badly in the long run. And lastly, reach out to other utilities. The great thing about this industry and the great thing about the rural broadband market is almost everybody's willing to talk and say, hey, here's what we've done. Here's what worked. Here's what didn't work. Here's what I wish we would have done. talk to as many people as possible, and then feel free to use us as a resource. I've been in the industry for over 8 years. I'll gladly make phone calls and connect you with different people throughout the industry that have been doing this. And we're happy to help out any way we can. So with that said, that concludes the presentation for today. I appreciate you guys joining. Thanks for signing up and hanging out with me during the lunch hour if you're on the East Coast. And with that, we can open up to any questions that you guys may have. All right. So I've got, I see no questions during the webinar, but now that we're all wrapped up, I'm happy to open it up to you guys and ladies. Don't be shy now. All right. Well, I know we're right at the hour, so I will hang out here for another couple minutes just in case anybody thinks of anything. But if not, again, yeah, appreciate everybody joining us in today. I hope this was helpful. Hopefully you learned something new. If you think of anything down the road or have any questions, feel free to call or email me. Happy to help out any way I can. So I appreciate it, everybody.